Hello friends, welcome to our online session in chemistry. Today we will see simple oxides. A binary compound of oxygen with another element is called an oxide. Oxides can be classified into four categories. That is acidic oxide, basic oxide, amphoteric oxide and neutral oxide. First we see what is meant by acidic oxide. An oxide which dissolves in water to give an acid or reacts with a base to give a salt is called as acidic oxide. The examples are SO2, SO3, CO2, etc. Here sulfur dioxide reacts with water to produce H2SO3 sulfurous acid, which is the acid. Generally, oxides of non-metals are acidic oxides. Then next to this is basic oxides. An oxide which dissolves in water to give base or reacts with an acid to give a salt is called as basic oxide. Calcium oxide, barium oxide, these are the examples of basic oxides. Here calcium oxide reacts with water to produce calcium hydroxide, which is a base. Also barium oxide reacts with twice HCl, which is acid, to produce barium chloride, which is a salt, plus H2O, water is produced. These are the basic oxide. Mostly metal produces such a type of oxide. Then next to this is amphoteric oxides. The oxides which reacts with the acid as well as base to give salt is called as amphoteric oxide. Example is Al2O3, aluminum oxide, which reacts with acid as well as base. In first reaction, this aluminum oxide reacts with the acid HCl and water molecules to produce a salt. In second reaction, this aluminum oxide reacts with base NaOH plus water to produce a corresponding salt. Then fourth type of oxide is a neutral oxide. The oxides which are neither acidic nor basic are called as neutral oxide. The examples are carbon monoxide, nitric oxide, NO. Then N2O, nitrous oxide. These are the examples of neutral oxides. Then next to this is ozone, that is O3. Ozone is an allotropic form of oxygen. Oxygen in the upper atmosphere absorbs energy in the form of UV light, that is ultraviolet light, and changes to atomic oxygen. This atomic oxygen then combines with molecular oxygen to form O3, that is ozone. The layer of ozone protects our Earth's surface from harmful UV radiations. Therefore, it is called as ozone umbrella. Then, preparation of ozone. Ozone is prepared in the laboratory by passing silent electric discharge through pure and dry oxygen in an apparatus called as ozonizer. As the conversion of oxygen to ozone is only about 10%, the product is called as ozonized oxygen. Here the reaction is given thrice O2 gas gives twice O3 gas, that is ozone. Delta H for reaction is a positive, implies that this is the endothermic process, means heat is absorbed in this reaction. Then properties of ozone. First property is ozone is pale blue colored gas with a characteristic pungent odor. It is a pale blue colored gas. Then ozone is diamagnetic in nature. It is the second most powerful oxidizing agent after fluorine. Means after fluorine, it is the second most powerful oxidizing agent. It liberates oxygen gas when acting as an oxidizing agent. Here the oxidation of Fe2 plus to Fe3 plus is given. Here this ozone oxidizes this Fe This reaction is given here. Then next to this is chemical properties of ozone. First is oxidizing property. We know that ozone is a powerful oxidizing agent as it easily decomposes to liberate nascent oxygen. This O3 decomposes into O2 plus nascent oxygen. Here nascent oxygen is produced by this ozone. This ozone oxidizes lead sulfide to lead sulfate and iodide ions to iodine. Here this lead sulfide reacts with this 4O3 gas, that is ozone. Then lead sulfate is formed, PbSO4, and 4 oxygen molecules are liberated for O2 gas. Then potassium iodide reacts with this water and O3 gas, ozone gas, to produces potassium hydroxide plus iodine gas is produces, and also there is the production of oxygen gas. Then this ozone oxidizes nitrogen oxide and gives nitrogen dioxide. NO gas reacts with this ozone, gives nitrogen dioxide plus O2 gas. This nitrogen oxide emitted from this exhaust system of supersonic jet aeroplanes. This nitrogen oxide, which is responsible for depletion of ozone layer in the upper atmosphere. Then bleaching properties. This ozone acts as bleaching agent due to its oxidizing nature. This O3 ozone produces nascent oxygen plus O2 molecule. This colored matter reacts with this nascent oxygen to produces colorless matter. Means bleaching property means it is used to remove color or stains from these materials. This ozone bleaches in absence of moisture, so it is also known as dry bleach. It is also useful for dry bleach. Then second is reducing property. Ozone reduces peroxide to oxides. Here this hydrogen peroxide reacts with this ozone molecule to produces water and twice O2. There is a reduction of this peroxide to oxide, that is a water molecule. Barium BaO2 plus ozone produces barium oxide plus twice O2. These are some of the reducing reactions of ozone. Then depletion of ozone layer. Thinning of ozone layer in the upper atmosphere is called as ozone depletion. The ozone layer in the upper atmosphere absorbs harmful UV radiations from the sun and protect us from these UV radiations. This depletion of ozone layer in the upper atmosphere is caused by nitrogen oxide released from exhaust system of car and supersonic jet aeroplanes. This nitrogen oxide reacts with ozone to form nitrogen dioxide, which is responsible for depletion of ozone layer. This depletion of ozone can also be caused by chlorofluorocarbon, that is CFCs or freons. They are used in aerosols and refrigerators and their subsequent escape into the atmosphere. The depletion of ozone layer has been most pronounced in the polar regions, especially over Antarctica. Ozone depletion is a major environmental problem because it increases the amount of UV radiations that reaches the Earth's surface, thus causing an increase in the rate of skin cancer, eye cataracts, and genetic as well as immune system damage among the peoples on the Earth. Then next to this is structure of ozone. This ozone O3 is an angular molecule. The two O-O bond lengths in the ozone molecule are identical, that is 128 picometer, and the O-O bond angle is about 117 degree. You can see in this figure. It is a resonance hybrid of two canonical forms. It is the resonance hybrid of these two canonical forms. The bond angle is 117 degree. Then next is uses of ozone. Ozone is used for air purification at crowded places like cinema halls, tunnels and railways, as it produces O2 gas. In sterilizing drinking water by oxidizing all germs and bacteria. It is also used for the sterilization of drinking water. Then for bleaching ivory. Ivory, it is a hard white material from tusk, that is the teeth of animals. Consists of dentine. It is used for bleaching ivory, oil, starch, wax and delicate fabrics such as silk. In the manufacture of synthetic camphor, it is also used in the manufacture of synthetic camphor, potassium permanganate, etc. These are the uses of ozone.